With a solid model on hand, always import the file into a Libre or SolidWorks first. Now in EasyCam, go to the File tab and use the Transfer button to bring in your solid model. We have to determine whether or not the coordinate system is in the right place. This location must match your machine datum. With On Geometrie, you can select surfaces to preview and align your UCS, user coordinate system. The x-axis is snapped lengthwise on the face. The center of holes are also an option. Let's take a quick look at World on 3 points. As you can see, the UCS is floating on the screen. Switch your pick point to all so you can snap to the center of holes and points of lines and so on. We are below the surface. To find out by how much, we click on the top of the part. The Z value gets copied to the clipboard. We'll use Translate to move the UCS in a positive Z. Select our world coordinate system and bring it to the top. Now I'll demonstrate rotating the part to line up with the fixed jaw. Check angle is very useful here. Simply pick two surfaces to find the angle between them. Here we have 80 degrees, so we rotate 10. Go to the Edit menu, Transform, rotate around Z. Make sure we are rotating around our origin, so X, Y, and Z are set to 0. Select World in the list box. Let's look at another method to align our coordinates. World on Model. Choose Top if you are touching off your tools on the top of the stock. In the picture you can see we have 9 standard locations to choose from. A selection of none creates no stock and leaves the simulation to size itself to the boundaries of the part. Right to stock settings. The sole purpose is to use the values here for simulation purposes only and not for generating machining paths. Create stock curve is an old method, but I'll show you how to apply a curve in just a second. Create stock surface is the most frequently used with solid models. This is a true representation of the stock in your machine. World on stock is used when tools are touched off on rough material versus setting the machine datum in reference to the finished product. You can add stock for individual axes or use the stock offset to be uniform. Now let's look at applying a stock curve. Create a new curve, stock CRV for custom stock. I will use Snap to Grid and create a shape that you can picture would come off of a bandsaw, laser, water jet, or plasma cutter. A little early in this session, but I will create an operation to demonstrate cutting this type of stock and how we include it in simulation. As you might guess, we will choose custom stock in our stock setup. Our toolpath is absolutely efficient with no wasted paths. You'll find more options in simulation setup. Outside of World on Model, we can choose to create square stock here, round, or custom. The behavior is similar to World on Model with our auto setup and create stock, but we can show the stock taking a glimpse at the results. After Show Stock, you can see our coordinate system in the lower left-hand corner is at XY0. Let's shift the stock to be centered over the part by 1/4 of an inch, which is half of what we added to our length and width. Now moving on to talk about tooling. Tools can quickly be changed on the fly without a library, but a good library is always a plus. Some users create them by the job. The library is located under the Post menu, and the tool library is the last thing listed. So where is EasyCam's extensive tool list located? You'll find that on the C drive, in the EasyCam W folder, EasyCam X33 for Express, and for Mill and Mill Pro, it's the EasyCam 33. We'll start with the inch library, since that is the unit of measure for this job. Let's look at the process for adding a new tool into an existing library. I will add a 1/2 inch end mill. To do this, pick Flat in the drop-down for the type of tool. If you have a dedicated tool in your carousel, assign that number here. In most cases, the comp number will be the same. Set the tool diameter, overall length that hangs out of the holder, angle if it's a tapered tool, dedicate in RPM, and feed in the X and Y, the max depth pertaining to the flute length, feed when plunging into material. If you look at the shank diameter, an excellent example would be a key cutter. And maybe add a comment. All of these settings can be changed on the fly if need be. I'll create a 3/4 spot drill. And you'll notice all the fields are pretty much the same. Feed XY comes in handy when you use a spot drill as a chamfer tool. Once you are done, hit close and save your changes. We'll create a new library. You can use the library manager if you have tools in the main library you wish to carry over, rather than start from scratch. Pick the existing library as well as the new library to send tools across from one to the other. After you're organized, save the changes. When you have a long list of tools, you might want to select by tool type, where this will save you a lot of time. You can access the tools you added to the tool library within any operation. The tool type is displayed and can be changed in the background. The tool number and diameter can be modified on the fly without the need for preset tooling. The length of the tool is generated automatically, assuming you are confident that the tool holders won't collide with the workpiece or clamps. Use the Select button to access your library. All your tool information is listed here on the right side of the window. You can make an informed choice. We offer a variety of tool holders for complete accuracy and simulation. Those too can be assigned in the library. Here is a list of tool types to choose from. We cover all the tools you will encounter. For custom tools, you need to consider upgrading to EasyMill Pro or EasyMill. By choosing Bull, we have the option to specify a corner radius. We'll make a few changes here for demonstration purposes to ensure that the settings you've made are reflected in the operation. Now back to the main window. The technology table is updated, applying your tool parameters previously set. With the new interface, most of the action happens on the right side of the screen, less cursor chasing and more getting things done. Tooltips appear if you hover your cursor, making the interface user-friendly. In the click of a mouse, you can customize the toolbars easily and add popular commands typically found in menus. When creating a facing operation, select the entire part to be understood as the tool's boundary. our 4-inch shell mill is ready to go and will successfully do the job. EasyCam determines the depth for us based on the selected faces and operation type. Let's talk about the types of toolpath we can choose from, starting with pocket. Here you will see the cutter takes a full sweep around in the shape of the boundary, starting on the inside or outside, your choice. The step over is in the form of a stretched letter S, rather than in the shape of the letter L, which was in the past, that would cause a hard stop. Zigzag is a great candidate for what we want to achieve here. The tool moves left to right, top to bottom, or at any angle we choose. High-speed machining sweeps into corners to avoid sudden plunges or sharp turns that could spike cutting forces. On the return pass, EasyCam lifts the tool slightly off the floor and uses your machine's maximum feed rate to get back into position for the next pass. Helical can be looked at like the yellow brick road. It's a continuous spiral until it reaches the end where the entire perimeter is cut. Centerline positions the cutter on center of the selected surfaces along the length or width. If the cutter is large enough, EasyCam generates a single pass. If the cutter is not large enough, EasyCam adds the necessary passes to complete the job. With our new version, you can verify to calculate and visualize the toolpath while the operation is open. Now we have all that material to remove surrounding our part. We'll use a pocket operation to remove such material. First, select the finished part, then include the stock. You do this by clicking on the third button to the right on top of the simulation toolbar. Once you create the pocket operation, we'll select a tool from a library I created for this job. Let's select the 1-inch tool. You will learn everything about this tool as you review its information, which I have highlighted on the right. The Z Allow lets you add a negative or positive value. Negative will feed the tool below the part by the specified value. However, even a 0 value will provide you with additional depth because there is no floor to restrict how deep the cutter can go. You can, of course, override any of EasyCam's automation. The through depth value defaults to 0.1, but you can change the default value in the EasyCam's INI file. Rather than hog out all that material and then cut against the finished wall, we will leave 20 thousandths for a finished contour. 50% or 0.5 are equivalent. You can choose the format. We use a percentage to scale for any tool size. Therefore, you have one less field to fill in. Over time, you will learn all the different dialogues that can be passed over, giving you the best programming experience and enabling you to get the cycle start faster. To start your cut outside the stock, we will choose outside milling. As you can see, the toolpath is below the edge of the selected surface, making for a clean cut. Here's a quick look at our high-speed machining. For this contour operation, select a single vertical wall, and all the associated faces will chain. Let's keep putting that library to good use. Again, if you have something quick to program, maybe change the values on the fly instead. Z surface. EasyCam determined the top of the selected surfaces. Let's examine the meaning of Z surface, rapid, and clear, and the benefits of each. Z surface is where the top of the feature is located. If your 0 is, say, at the bottom of the vise, your Z surface would be the thickness of the part for most operations. In this example, we have a pocket inside a pocket. Rapid is a distance above the feature when positioning in X and Y. Be sure that the value is great enough to avoid clamps. Clear is a rapid move above the feature once you've reached the XY position at the rapid height. Clear helps us to avoid feeding from the rapid position, which would be wasted time. When would surface height change? When the feature starts below the surface 1. As mentioned, we do not want to start feeding from the clearance of surface 1. You can imagine waiting a long time if surface 2 was quite deep. Toolpath like single pass is used for those semi-finish or cleanup passes. Multi-pass is one that behaves as a roughing operation with an offset to your profile. You add a total stock for the amount of material you wish to remove and a cut step for the approach. Z-Connect is used for those open profiles. Once you reach one end of the path, EasyCam feeds in a Z based on the value in Z step. This action continues until full depth is reached. Z-Helical, think of a corkscrew. The Z step is a value for each revolution. 3D slot is one that lies within the XZ or YZ planes. Plunge contouring behaves like a drilling operation. This is intended to remove massive amounts of material in the quickest way possible, so consider investing in a plunge mill. Fillet slot is used when the cutter is the same size of the slot width. However, if the slot is greater than the cutter diameter, we'll remove the material in the center. Select a fillet, and EasyCam places the tool tangent to the filleted surface. We are going to go with a single pass. You have the option for a stock allowance. This might be used for a semi-finish operation or to cut further into the work when the value is negative. Taper angle. EasyCam picks up on the boundary for roughing with multiple pass and a total stock, all without user intervention. And to make certain those ball end mills clean the entire face, use a negative Z allow. Fillets for either the top or bottom or both can be added. A thought here is to deburr the part with a top fillet. Offset direction, left for climb mill and right for conventional. You look in the direction of the path to determine your offset. Cutter comp is a hot topic, so let me break it down for you. In your G-code program, cutter comp generates a G41 for a left offset and a G42 for a right offset. When you choose machine as your cutter comp, the G-code output is directly over the profile, similar to engraving. To cut against the wall and not on top of it, you will define the cutter diameter in the machine's tool register. Some machines will require a radius value, but that does not seem to be the standard. Cutter comp both. The G-code that is output already compensates for the tool radius. So if the tool is already offset, the diameter in the machine's tool register will be 0. Maybe you will define a value in your machine's table to support a regrind cutter, tool deflection, or simply the amount of cutter wear. With a choice of software, there is no cutter comp. Now, lead in, lead out. With this unchecked, the tool feeds into the work tangent to your first move in X and Y. If you are not satisfied with EasyCam's default path, which is based on the cutter diameter, you can override it in the background. Ramp settings add an arc move to the start of the first pass. With no ramp or angle specified, the cutter path for the lead is direct. Overlap is used if you wish to pass the start point by a given value, mainly used to remove witness marks. Moving on, let's cut the material around the bosses. Simply select the face at the bottom, and EasyCam accounts for those islands. HSM is an excellent choice for this feature. You can maximize your speed and feeds, which will decrease the machine time. The smaller boss is below the surface, so we'll use a facing operation to mill the top. With a decent sized cutter, centerline is an excellent choice. It's obvious the tool is too large and has too much overlap to approach the part at a 90-degree angle. So let's look at 0 degrees and verify there are no violations. What you see here is what you'll see at the machine. Double-click the screen to clear the simulation. For through pockets, you will select their vertical walls to establish the tool's boundaries. Keep in mind, you can use the same procedure for open pockets without a bottom face. I was going to choose a 1/2-inch cutter, but let's use something that won't fit in those corners for a more efficient and aggressive roughing operation. The pockets are pretty deep, so we will remove the material in layers, using a Z-step. Let's also add a plunge to gradually feed into the material for each step. This helps clear the chips and takes the stress off the cutter. For this example, I will choose helical. The helical radius is the value measured from the center of the cutter. The end mill will advance 50 thousandths in Z for each revolution. An alarm is thrown due to a tight plunge area where the helical radius would violate the part, taking into account the tool's radius. EasyCam adjusts for that with a zigzag plunge instead. Another tip, you can use a rapid curve to define a more appropriate entry point. As we know, the previous cutter was too large for some of the corners, so we will go in with a re-rough to pick up where the last tool left off. There is enough overlap to give you a quality finish. For rest milling, choose our through pocket operation. And of course, you can change the default Z-step to accommodate the smaller tool. Let's finish up the pockets. Unlike the through pockets, our boundaries are determined by their bottom faces. SmartClick includes all pockets with the same Z depth. Now for our contour. We may have selected the vertical surface for this feature, but EasyCam recognizes that it should not violate the surface below. We'll apply a multipass, adding stock to the wall of the contour, allowing us to take smaller steps as we creep up against the wall. I will share a tip. We can take the total stock and divide it by the number of passes we wish to take. This is possible because every dialog is a calculator. Drilling holes is a breeze, no matter how many there are to machine. Select one hole, and with SmartClick, all the holes of the same diameter are included. To turn off SmartClick, just simply hit the Shift key and select individual holes. Z-step represents your peck value, but if you choose a drill cycle, there will be no pecking, just feeding to depth, and once reaching the bottom, the tool exits out of the hole with a rapid move. Spot face offers a dwell once the tool reaches the bottom for a complete cut. Deep hole will peck. It feeds to the Z-step, retracts completely out of the hole, rapids back into the hole just above the last peck, and feeds down to the next step and repeats. Tap is self-explanatory. Chip break is similar to deep hole, but the retract is slight. Bore, FDF, is feed, dwell, feed out. Bore FF, feed in, feed out, without the dwell. Now for our 1/4-inch holes. Again, all similar sized holes are selected with SmartClick. Although we can add the chamfering feature to our toolbar, as mentioned in the beginning of the video, for now it is found under the Work Step menu. On this model, we have 3 chamfers to machine. You can skip the chamfer size and angle. EasyCam has you covered and supplies the values based on the selected faces. There are many ways to machine a chamfer. The tool options include chamfer, flat, ball, and bull. With any tool, you can feed from the top to bottom in smaller increments along the tapered angle. Just add a Z-step. SmartClick is activated for chamfers using the button just above our simulation icon. Because all the information for our other chamfers is the same, I'll duplicate the operation and swap out the faces. To remove the prior face selection, simply click outside the part and all the faces are removed for you to select new ones. Duplicate as many times as needed. When you verify all, we present you with the cut time for all operations, great for quoting jobs or predicting each machine setup. Before diving into simulation options, let's look at a few other features that may be important to you. For one, the Work Step Manager. Here you'll find all your operations packed neatly together for global editing. I'll slide the tool number next to the diameter for better organization. The chamfer tool is common among the last 3 operations and should share the same tool number. There was a mistake in the tool diameter, but luckily we caught this. And we'll change the tool comments for a better description. How about changing the order of operations? Highlight the operation you wish to move in the list and use the right and left arrow keys to place it in a new location. When you select an operation in the list box, the machining surfaces are highlighted to easily identify what is being machined. What if for some reason you do not want to include an operation in the G-code or simulation, but you don't want to delete it? Right-click and choose Deactivate. This process might come in handy if you wish to generate more than one program. Deactivate what you wish to exclude, post your program, and swap the operations by reactivating and deactivating. Let's talk about SmartClick. When it is active, it may select more faces than you wish to machine. So what do? Well, you can turn it off by simply hitting the Shift key on your keyboard. This will allow you to select those faces you wish to include or exclude. Hit Shift again and you're back to automation. If you see something in the simulation you wish to change, go ahead and double-click the feature and the associated operation will open for editing. There are many options to discover that are related to simulation. One of them is the simulation speed. In the stock setup, there is a slide bar, which can be added to any toolbar. And during simulation, you can increase the speed by hitting the number 9 on your keyboard. And to slow things down, you'll use the number 1 key. 0 equals a pause, and you hit Enter to advance the tool each step. Rather than watch the tools go through the simulation again for all proven operations, you can pick the start point in the list box. All you need to do is check the From Current Work Step option. Select Show Holder is one of the most commonly used features. Not only is it visually appealing, but when working in deep cavities, most people would agree that this is a must-have. You want to catch mistakes on screen before they happen at the machine. Create uncut solid, or what can be called part compare. You can check how well you programmed with this feature. Did you machine everything according to the model? Green equals machine to the solid model. Yellow, an undercut or gouge. Red, there's more stock to remove. How about clash detection? Did your holder hit the part, or did you crash into a fixture? When there is a collision, EasyCam stops the simulation, and the work step that caused it is highlighted in the list box. Do you want more information about the cut surfaces on your model? Set your detection type to features. After the simulation is run, EasyCam analyzes the results to provide you with the details such as dimensions and angles for the selected face. The Save Simulation option allows you to click on an operation and view the progress that has been made up to that point. Step type determines when the simulation should pause. Z wrap it up will stop the simulation when the cutter retracts in Z. Work step causes a simulation to stop after full simulation of the previous operation. Tool change gives you a heads up if the next operation should use the same tool as the one just simulated. Now for posting your G-code. Recently selected post processors are displayed here, so there is no need to open the directory each time. Let me point you in the right direction. Our post processors are located on the C drive, EasyCam W, EasyCam version number, leading you to the mil-inch post library. This is the default location if you did not change the directory during installation. Listings. When posting G-code, do you want to watch the simulation in wireframe, better known as verify? Did you want to watch the G-code scroll through to the end? Use the G-code? Or will you choose simulate for a solid preview? After the code has been calculated, do you access the file in Windows Explorer by choosing None? Do you open EasyCam's RS-232 program with EasyDNC? This is included. Or are you going to launch the notepad? Most machines are already supported. A post processor exists to provide you with accurate G-code, and if the machine requires an extension other than TXT, we support it. I want to thank you for watching. I hope your experience with EasyCam gets you to cycle start faster.